And good evening, everyone. If you can hear me, I can see that you probably cannot. Let me fix that. Just a second. Let's make it a little bit, a tad louder. Probably noisy, but at least I won't need to just stretch myself to the microphone. Microphone is I'm using my current my normal microphone just as an overhead mic. Yeah, that's gonna be pretty loud, but there's a limiter. So now everything seems to be working. Good evening, everyone who is watching the stream of VOD arrives on air, and welcome to my rare type of stream. I kind of always say that I'm going to be doing it. I always think I'd be doing them more often, but in fact, it's kind of a little bit hard to make it all work. A creative stream where we just do stuff. So, the Captain Pyro, nice to see you, welcome, and of course, lurk away. Thanks for jumping in. So, if you're hearing music in the background, you are on Twitch watching live. If you are anywhere else or not live, you are not going to be able to hear the music. Use your own. So what's going to happen? I have a bunch of things that I just need to assemble. 3D printed cases, some boards from AliExpress, and those are going to be power supplies. Let's start with the one that's sort of kind of very basic. It's just going to be a 9-volt power supply. I even printed it here. So nothing special. Just this. So let's start assembling it. A board that kind of gives you 9-volt. I just wanted to have a power supply that can be like mounted upside down underneath the desk. This design, in this case, I've actually even posted it on Thingiverse, so I designed it quite some time ago. So I don't have a 3D printer, I order printing, so iterating design-wise is a little bit hard, but this one is just a modification of the one that I made for another board of similar type but slightly different. This one is XPJ 01E, and the other one is like XPJ 16. We'll get to that. So that's only the first one. The second one going to be a little bit more custom. That's going to be the second one. Slightly larger case, but the same idea, and way more stuff. So I managed to kind of design it a little bit upside down. So 9 volts on this side, mains on this side, so it goes in like this. The holes are not perfectly aligned in the case and the power supply, but that's not a big deal. So unfortunately, I totally forgot about the fuse, because this device doesn't have a metal case. It doesn't have a ground. So it doesn't have a metal case. It doesn't have like anything metal exposed besides the sleeve of this connector that's output. So technically speaking, if it doesn't have a metal outside, it doesn't need to have proper grounding. But grounding is protection. Fuse is another way of protecting devices. So I would really like to actually have a fuse here. I forgot when I designed this thing. I forgot about like room for the fuse, and there's not much room here left. So this one's going to be without a fuse. 9-volt power supply mounted under desk or on a wall like this. There's like the steps with holes. So pretty much that's for my second PC, for a small headphone amplifier. not for a small, not headphone amplifier. It's a headphone amplifier, but it's a digital and analog converter DAC, so-called DAC. Very expensive. Used to be very expensive. Still considered expensive. Not like expensive, but it's not like a $10 board from AliExpress. It's more than that, way more. So, but the power supply that was offered with that device, it was very bad. I actually told about it multiple times on stream. I think we even experimented with that DAC on stream. So, and I was able to show that the power supply of the DAC introduces a constant sort of interference. So I tried it with another power supply, universal power supply, that's a little bit too big to use it constantly for that digital audio converter, and it was totally fine. No interference, nothing, way better sound in terms of just, well, no annoying. It wasn't hiss, it was like, no, sort of kind of hiss. Okay, it was hiss. So this is simple. The only thing we're going to need, it's like some thermal shrink tubing. Let me get some. Always forget about this stuff. So it's going to be pretty basic. This you solder to here, and this you solder to here, and that's it. So just let's see if we have it. Yeah, we can mount it like this, can we? Yeah, we can. Perfect fit. So I designed the walls of this case a little bit thick, so but they are like not filled entirely. There's like a pattern inside, you can see it, so it's not 100% fill, of course. So let's see how long are we going to need them, because we absolutely don't need a ton of wires inside, just the right amount. So let's start working on it. So you know how it is with the mains. One wire is live and another one is neutral. In case of this device, that's like live, neutral, agnostic, can go both ways, because it's going to use this plug that I kind of like for low power devices. It's IEC something. I don't remember which one. IC something C7, C8, something along those lines. Okay, so let's just see how long it has to be. It doesn't have to be long at all. It's like maybe like this. That would be even more than needed. But these are, of course, the wires we can bend. I'm sitting on my headphones cable. So if you cannot hear me, if you cannot see me, if something is wrong, please tell me right away. So I don't have my small knife here. I'm going to use this one, which is a little bit of an overkill. I don't remember how these connectors are called. So let's readjust this camera. Don't remember how these connectors are called. XN probably something. XJ, I don't remember. Well, almost all boards from AliExpress that are power supplies. Well, a lot of them, and a lot of other boards that are more or less finished products. It's just a board without a case, PCB without a case, but already pretty much assembled and working. So a lot of them use this type of connectors, which is sort of kind of convenient. And I got a bunch of these just for the future use, and now I'm cutting them the way I need it. So sometimes you buy a board like this and you get some tails, some connectors with it on AliExpress. Sometimes you don't. Really just sort of kind of almost a lottery. So small cubing for shrinkage. Yeah, because this is going to be mains and 220 volts, 230 actually, or 240 sometimes even. So I don't want that to be, anywhere exposed outside of the board. So at least I'm not trusting my own soldering for this to be like exposed. Unfortunately, this one is not copper. This one is not copper. I would like everything to be copper, but cannot have it all, I guess. You're going to fit. I have a problem of picking always around diameter of thermal shrinking tubes. So I always end up like doing wrong ones. So the ones that end up too small. So let's see. Kind of goes in this direction, so it has to be like this. My very dirty soldering iron. Let's at least fix it somehow. Clean it somehow. In this. Ow. It's hot. Not the best way, but it'll do for now. We are not soldering anything that's really sensitive to the cleanliness or not cleanliness of your soldering iron. We are soldering super basic things. So let's see if we, oh, I forgot actually the solder itself. A little bit would be nice to have, and maybe a helping hand here, third hand so-called. Just something like this. Yep, to prevent it from moving. Prefer it to be the other way around, but I think I can manage. So there's enough solder on the soldering iron already from the previous usage. Pre-soldering. Adding a little bit of solder to these tabs here. Don't need much. And yeah, I do it in a very classical way. I use, well, pretty much standard solder, but as flux I use pine rosin. It's super classics, like good old, and I like it. I like it the way everything everything about it. Okay, now let's add some solder to the wires. This is gonna be a little bit hard because they're not copper. So far I added only a ton of flux. Well, flux is not a problem. Pine rosin. It can make things dirty, but just a little bit. How should we go from upside down or downside up? Doesn't matter. Let's just do it. Oh, that's a big blob of solder. Okay. It's so big I might not be able actually to put on the shrink tubing. Oh god. Okay. I was able to. But it sits there very tight without any shrinking, without any heat shrinking. Oh, you actually can see a lot of my head in the frame. Apologies for that. Where's the other tube? I lost the other pre-cut tube that I had. Oh no, it's here. Oops, it's just rolling away. A little bit too long. They are. So very basic soldering. Nothing special. Okay, everything got to be heated though for the solder to work, because you can leave a blob of solder and it might not mean that the things are actually together now, fused. So okay, so now we have this one. Before shrinking anything, let's see if it fits. Well, I mean, it does fit. If it actually goes in the case, if it can be plugged. It's supposed to be plugged. Yeah, it can. So everything is good here. Okay, one's done. Now another one. So this one's a little bit tricky, because even though the output of this board is just plus and minus, plus 9 and 0 volts, so plus 9 and then minus, well, not minus, 0 volts, the difference is 9 volts. This one has three pins. It's a pretty sophisticated thing for this small and seemingly very simple device. Actually, it has 3 pins because it's supposed to play another function. It's not only a connector for your power output or input. I use this one as output, but well, usually they're supposed to be used as like input ones, so they're supposed to receive power, not to send it out, so not to transmit it. In case of using them for receiving power, they are connected not just to the powered device, powered circuitry, they're connected to the battery that powers the same circuitry. And the thing is that when you plug when you plug external power into this one, it disconnects the internal battery, if it's all assembled properly, of course. We don't need this functionality. So, but I always confuse things. So where's the plus? And where's the minus? Where's the central big pin? Where's the sleeve? So as far as I understand, it works like this. So I have just a cable with a barrel plug here. So without the plug in, the barrel plug in, two of the pins are connected. But when the barrel plug is in, two pins they get disconnected. Why do I? Yeah, beeper. So we have the minus now. Yep. So this is the plus and this is the minus. So next to it, next to the plus, and you can see that it's a plus because it's the tip connects the tip. Okay, kinda reminded myself of that. Now to the okay, always check if your connectors go through the holes before soldering anything. You might end up with inability to put things through. So in this case, you'd have to solder it like this, or like this. But this one goes through, so it's actually pretty convenient. So this one has to be like super short, but I'm afraid of cutting it like super short, so that I don't like, that I don't want. These ones we are not going to need to really insulate, but still, why not? We have thermal shrink tubing, why not to use it? Even though these cables, these wires, they are not copper, I really like the insulation sleeves on them, like so easy to work with, and they are very bendy, they're not stiff. Really easy to cut and then to remove. Don't even need to use your teeth, just fingers, without cutting any strands of the wire itself, which is nice. Okay, let's cover them and solder too. Everything has to be covered and soldered before actually being soldered anywhere. gets dirty very fast when you use just pine rosin. And without pine rosin you cannot heat up really anything. And if you cannot heat it up, it's not taking the solder. So technically, by the way, so the mains here, that's the mains, it's soldered. You're not supposed to solder the mains, but in case of low power, well, what you gonna do? If it's like low current, and it's going to be like milliamps on 220 volts, so a little bit of solder, and preferably without covering the hole. Oops, and I properly covered the hole here. Okay, I'll get through with the wire itself. For this we are going to need definitely some larger heat shrinks. Yes, I'm going to use heat shrink tubing even for this one. So if something is not in focus, please tell me, because I use manual focus cameras. At least they were cheap. So a couple short ones. I tend to make them, I tend to use the ones that are not, by the way, let's see if it's really plus and minus. I never really checked. Yeah, because the way since this cable, this cable with this plug, it's like my own, and this is like a different thing completely from a different manufacturer, different seller and whatnot. So the color code is the other way around. So here the black one's going to be plus, positive, and red one's going to be the negative. So not really obvious, not obvious at all, but what are you gonna do? It doesn't have to be this long, but I made it this long. Soldering it over my finger. Well, good enough. Okay, that was plus. And this one, the red one's going to be minus in this case. Going to be a little bit harder since I need to make a hole. Left-handed soldering. Did it work? It did, by the look of it. Yeah, I forgot the the tubing. Yeah. Always put on your tubes before soldering things in. Okay, let's try again left hand soldering, since my helping hand is on this left side. Sorta, kinda, sorta. Okay, so let's install everything. Well, let's connect everything and try to check it before actually installing. Though I think I will have to screw the board in one way or another, because otherwise moving boards, that's not gonna be fun at all. And let's shrink it. Not that it's really needed or anything. But I just prefer to have them. These ones are actually sitting so tight they don't really need any shrinkage. But let's give some to them. So technically, yeah, you're supposed to have a metal case for things like that. In order something gets loose, in order something that's carrying the mains gets loose. If it's like the life, then it gets shorted to the case that's metal, and the case is grounded. Everything goes to ground, and everything's safe. In case of a plastic case, something that's life carrying gets loose, and well, it stays loose inside, and then it might, for example, get somehow connected to the output, but that would be like a stretch, really a natural stretch. So this goes here like this. This goes here. Or did I make a mistake? I did not make a mistake. I thought I did, but I did not make a mistake. Everything is right. This has to be like this. Very basic power supply. So you can buy like power adapters like this in just a wall plug type of thing. But well, I mean, I bought actually one from AliExpress, 9 volts, and I ended up breaking it in like 3 minutes. So I decided to do this one because I've been ordering these XPJ boards. Though it's 9 volt, this one's 9 volt. I've been ordering 12 volts and they seem to be kinda okay-ish. Okay, before screwing in anything, let me get the cable for the mains. I have a couple of wall sockets under the desk that are switched. Just a second. Here we go. Let's see. So after powering this on, I'll have to be careful because it's going to store some power after even turning it off in the capacitors. Well, just gotta be careful. Right now it doesn't have any power in there whatsoever. So let's give it some. Here we go. The LED comes on. Okay, let's check if we have the output voltage here. Oh, this one is going to move away. Here we go. Again, I really got to be careful. Don't try it at home because on this side we have live mains, 220 volts, which is unpleasant to touch. Let's put it that way. Okay, some volts here, and let's see if I have the polarity right. Okay, for you to see it, let's make it visible without shorting anything. So that's supposed to be the minus, the negative one. That's supposed to be the plus, and we have clearly 9 volts, which is what I wanted to actually have. Turn it off. 1, 2. It's off now. Here we go. So the LED is off. There's no mains here, but that doesn't mean that it is safe now. It's not. Know about this. These capacitors are pretty small. They still can shock you in a very unpleasant way. So got to be careful. Normal boards supposed to actually have a drain resistors everywhere, so they would just drain the caps. Kinda a little bit after turning the power off, but well, I mean, who really cares about that stuff? So okay, let's start assembling things together. Oops, yeah, my hands are not really small enough for this. So you're not supposed to use these sockets for outputs, but at least it's like a very common low voltage connector on this. So if you use something else, might end up misjudged. In order to avoid any misjudging, I even marked this. Okay, I don't have the right, of course, wrench here. I'm just going to do it like this. Okay, once here. Okay, now let's attach the board maybe to the stands. As you can see, there are stands there that I printed was in the design. I have a bunch of screws for that, some small ones, and some really small ones. I'm curious, I have a ton of these. Can I use the smallest ones? They're kind of expensive. I should design things around less expensive screws. So something that's common, like 3mm stuff. I keep like designing it, how it goes, how it designs. Yeah, they are not magnetic, which is sort of annoying. Yeah, they are not magnetic. I don't like it. So gonna have to use tweezers then, if I find it. Found the big ones. Gotta get the small ones. Cannot really feel it holding it in there. Okay, one's in. Let's see if it's going to hold it. Yeah, it kind of does. Okay, cool. So since the holes are not 100% aligned, we'll have to be creative here a little bit. It's my design, so sometimes things don't get aligned and require another iteration or a couple iterations. So you probably can see how it's like not really aligned. Well, it is what it is, I guess. Hope not to break the board. But on the other side, it's not going to be moved around. It's not mobile. It's absolutely for home use only. So, okay, 3 out of 4. I think that's enough. Because the third one, the fourth one, it's like completely out of alignment. And yeah, these are just screws. They're not penetrating the case. That's the way I designed it. So everything stays inside. No contact with metal except this. Actually, and I think the way this connector works, this socket works, it's disconnected from, like, it's negative. It's disconnected from the negative until you plug the barrel plug in. So okay, and for this we're going to need a little bit of 3mm stuff. Just let me get it. Here's some M3, just a second. Okay. So let's see. We need something short, but not really that short. That will do, kinda. Pretty big ones. Or if we use something with smaller heads, it will gonna go inside even a little bit farther inside. Will give us more thread to attach a nut to, and won't be that prominent on the outside. Well, you kind of supposed to mount these from inside, but in my case this really doesn't matter, and since I use like nuts and bolts here, yeah, Pretty much would be impossible to just detach completely. Some knots. So basic, but gonna work 100%. Yeah, this is gonna be pretty hard to do like this. Would be way easier to do it not outside, but I kind of want to have the head of the bolt outside. Holding it with my finger inside, hoping it just threads somehow. Yeah, it usually does. Okay, one's done. Again, I'm reminding you that since we've powered this board on, the caps might actually have some charge in them. They usually do, and what I'm doing here, don't try it at home, because this can be very unpleasant, the shock the caps that they might give you. I'm kind of avoiding touching the board at all, while just pretty much shoving my fingers deep inside the box. Okay. Okay. Come on, grab it. This one. Here we go. Nothing going anywhere, nothing moves, everything is fixed, everything is attached. Now delete. And this is going to be ready. At least I marked it 9 volts, just to remember what it is. And this amperage here, max current, is like really arbitrary, because who knows, this board's supposed to, yeah, there's no current rating on this one. By the way, it says it has a fuse there. At least that's the silk screen on the board, says that this one's a fuse, this orange thingy, with the look of it. Well, I mean, let's hope it does, because I forgot to add my own fuse to the board. Okay, to the device. Will this one work? Let's see. Yeah, it's a little bit too tight, because the holes here, they are not that big. I don't want to crack anything. I'm going to use the smaller ones, maybe longer ones, because I have a bunch of long ones that I have no usage for. Oh yeah, they are not needed. They do not need to be this long, but since that's what I have. I mean, I bought them. There's a lot of things, a lot of stuff like that I buy and I have no use for. It was like a mistake. Okay, this lid is going to be like almost weld on there. weld. This one's the same, seem to be. The way I designed it, you can actually put very long ones in there. So kinda 3 centimeters long ones if you want to. Here we go. So I never checked actually this board, if this board's noisy, if it produces any interference, because this is going to be used for a digital audio converter. But gotta be honest, it's pretty hard to design a PSU that would be worse than the PSU that digital audio converter actually had. Here we go. So pretty solid device, and for connecting it to power, I will have to make a cable like this. One way goes in here, and the same barrel plug, this one doesn't have, not the same actually, slightly different barrel plug going to be on the other side. Maybe not what you would expect from a power supply. That is pretty much like a wall plug power adapter, but at least you can use different cables with it, and you can mount it somewhere. It's not going to be hanging anywhere around your wall outlet or anything like that. Okay, this one's ready. The next part's going to be a little bit harder. Probably got to get a drink myself first. So the next part, oops, I'm already losing things here. This power supply is going to be way more custom. So, and I forgot to add a fuse to it when I designed it, so we might try to look for the room for a fuse. So this one is going to be absolutely not standard as heck. So so this one's going to be something like this. So this board receives the wall voltage, the wall outlet voltage, so 220, 230, 240 volts, this one, and it produces 12 volts on this side. Then these 12 volts, they go into each of these boards. They are pretty basic low power buck converters. What does it mean, buck? I have no idea. To my untrained non-English ear, buck doesn't sound like anything at all, but what it means is that buck means step down. So these are small boards for stepping down the voltage. So they're going to step down the voltage to whatever I actually set them to do. They have like these potentiometers to precisely change the output voltage, and then they're going to be actually outputting the voltage in these USB sockets, which is insane, absolutely non-standard. It'll probably break any USB device if anybody decides to plug a USB device in here, but that's for light, for LED panels for the flowers. they run like 12 volts on 12 volts, but a little bit lower. They actually can be adjusted, the brightness, based on the voltage. So this is of course all experimental, and these step down buck converters are to lower the voltage from 12 volts to, like, I think I'll adjust it to 10.5, and there's 3 of them, not one, because they are really small ones. I don't think they're powerful enough to handle like 3 outputs, 3 lights, so I decided just to do 3 of them for 3 different LED panels that they're going to power. As for the fuse, this board has a fuse too, as you can see, this, but I want to add my own. This is a fuse, standard fuse socket, gigantic for this actually case, but what you're gonna do? So, and I think maybe we can find a room for it somewhere here, if we are lucky, like somewhere here on the side. Not here, I'm not sure it's going to work, but maybe here, and maybe if it's not low, if it's not low, it fits, like clears the cap definitely like this. This step we can bend a little bit, I think, out of the way. So yeah, like this. And this is going to be actually permanently attached, not like this one's in the previous box. This one's going to be permanently attached, unfortunately. So let's see. Let's start with this part that's probably gonna be the hardest part. So we need to drill a hole of which size? So standard fuse holder. So drill a hole of which size? Let's measure it. 12. That's a large hole. 12 millimeters. Crap. That's a fairly large hole. So if we just use this as a sort of a marker, so that's the size of our hole here, and if we just maybe move it a little bit up, just like this, then we might actually really get away with it. So let's mark it with something. I don't think I actually ever drilled 3D prints. Not supposed to be hard, but I don't have another box like this if something goes wrong with this one. So sort of kinda, yeah, cannot leave a mark on this. Here we go. Okay, 12 millimeter. Okay, I have of course step bits. So let's see. So 12, to be honest, 12 millimeters actually seems to be pretty big. So let's measure it a couple more times before drilling. Where's it? Well, it shows that it's like 11 and a half. See? So I guess 12 it is going to be. Let's see if I just destroy okay, maybe I should first make an indentation with something. My what's called the thing that's for puncturing holes. Okay, let's use just a screwdriver. It's actually fairly hard plastic. I don't remember the names of the plastics that I used for 3D printing since I don't print myself. Yeah, you cannot see anything. This way at least you can see something. Oh freaking hell. How do you... It's out of focus, but at least... Okay, it's not... I don't think it's... It's not 12, not even close. Yeah, we need one step down. We're just starting going down so fast. Started going down so fast. Okay, here we have it. One additional unplanned hole. Let me get rid of all these shavings. And let's see if the board actually sits there. Okay, the board does sit. It's all tight. It's going to be, yeah, super tight. But we have a fuse. And again, this is, since it's for how's it called? Plant lights. So LED panels that are for just giving some light to the plants. This is going to be again mounted upside down like this under some surface out of the way, and it's not going to be like moved anywhere. Okay, I actually wanted to grab a drink, so give me a second, be right back. Works, this doesn't. Interesting. It works like this. Okay. And I am back. Just a second. Got myself an energy drink. It's not that it's hot here, it's not, but the energy drink is just room temperature, and I don't want it to be room temperature. I don't want it to be like brain freezing cold either, so just a little bit of ice. It's not in the freezer. It wasn't in the freezer. I just kinda have a little bit of ice there. So now the most tricky part of this build is going to be not to just drop this glass onto something, not to pour this over everything, not to flood the whole desk here. So yeah, it's just water. It's not sticky. The glass is in water outside. Cheers, everybody. I guess it's gonna be like this. A little bit of SMR. Okay, so now the hard part. Since this is going to be all sort of kind of just like this, and it's not going to be possible to remove it after soldering the wires. Oh yeah, one small problem. This hole is not available when the socket for the fuse is fully in. Okay. So, but at least it fits. It's going to be like this. And then like this. And then like this. Technically, I don't need these plastic washers. They are probably for metal. But the nut for this thing, it is metal. It is pretty much very metal. Yeah, okay, so gonna look a little bit sort of kinda old school because of this fuse socket, but nobody's going to see it. It's gonna be tucked away really nicely. So let's start soldering things, I guess. Again, let's start with covering them in solder, then cutting some wires to the length. What I do really good, I close the holes immediately really good. Technically, you can use a needle if I find one. Or just a little bit of that's too thick. Closing holes, that's not what we want. Here we go. Got the hole back. Okay. This is ready. The fuse thingy. The fuse holder. This one's going to be a tad easier. Though sometimes seemingly absolutely without any explanation, yeah, some of them would just refuse to take solder. Some parts of pretty much the same tab. Okay, so this is going to be a little bit trickier. This one has to be in place. We won't be able to move it after. This, so where is it? This one. One cable, one wire will have to go to this thing, and another one will have to go to this thing. So yeah, pretty complicated it's going to be, and because of that, all complications, they mean things have to be a little bit longer. First, let's measure the distance from here to here. This doesn't have to be like super long, but I'm gonna maybe give it more. Okay, I'm going to use scissors to cut this. Apologies. So maybe I just created myself a ton of problems. But if I did, I have more plugs like this. I have more connectors like this with wires attached to them. So this goes here, and another one goes there. Okay, let's see. Knife. I brought another one. Oh, let's use this one. This sleeve is not that easy to remove. So yeah, I think I moved my overhead cam a little bit too far. Gotta move it back a little bit and then tilt it like this, because you can see a lot of my head in the frame, a lot of my balding head. Okay, so let's prepare these wires too. Yeah, the insulation, the sleeve moves because of heat on these ones. So on the good ones it doesn't. At least not that easy. Let's make them a touch shorter. So the idea is that one goes here, another one goes there. Okay, let's start with the easy part. And thermal shrinking tubing. Let's not forget about that part. I like everything covered in this. So this has to be like this. So this goes here. And then this goes here. Helping hand. Don't forget to move your shrinkable tubing out of the way, because it will shrink from the heat from the soldering. That will do. Then it goes in here, and after we move it here, it just stays in here. Yeah, after we solder this one to this one, it stays in there. So we need a short piece of wire to connect this and this terminal pins here. Let's make it this size. I don't need the needle. Well, I mean, right now. Boom. So don't need to make them, to strip them for long, to make like, to expose a lot of strands of the cable. Absolutely don't need that, because these ones, they shrink when you start heating the thing up. When you heat the not the shrink, well, when you heat the whole thingy up with a solder while soldering it to something. Hope it's not too short. It's not supposed to be. It's actually, if anything, it's a little bit long. These are razor thick wires, though not like thick, but thick enough to, for example, power up a desk lamp with like the walls voltage, walls power. wall power, and that's because on this side we are dealing with actually exactly that, just the mains. That's the power we are dealing with. I'm learning to cut them shorter and shorter, not this one. This one here. Helping hand. Come on. Gotta straighten it a little bit, like this. Okay, so this side is soldered. So this is going to go like this. Now the hard part. The hard part is that we will have to solder this thing here in situ. And it's probably got to be like really short. So this one got to have like normal length. Like this. And this one has to be like way shorter, but that will result in inability to actually solder it properly unless doing it like this. So maybe I can actually make it shorter a little bit, just to avoid the clutter of these wires inside the device. Though maybe I'm creating myself a ton of problems for over nothing. The less you have these wires inside the device, the better. Okay, so now the hard part. First of all, this part here, you can get out of the way for now. So let's find the right heat shrink for this one, since we put everything in heat shrinks. So this one, okay, it fits. Oh, I forgot to actually deal with these ones. Let's shrink them while we can. Like this. The mains, it's better to be safe. And then a little bit more safe than just safe. Okay, so this one doesn't look like I properly covered and soldered even. the strands don't stay together. Okay, a little bit better. Come on, go in there. Oops. Did I break something? Sort of, kinda, a little bit by bending this tab a little bit too much, but I think it's gonna be okay. Well, not famous last words is just not going to work if I broke it off. But doesn't look like I broke it off, it's just a little bit of plastic. Okay, this one's here then. Like this. And this one goes here. That's a stretch. Ah, yeah, that's the parts are falling out. Falling off. Broken parts. Let's see if I can solder it. Well, I should be able to anyway. Though this step, yeah, sort of, kinda, maybe if I just do it the other way around. Yeah, it's hard one way or another. Where's tweezers? I used them at some point and I'm not seeing them anymore. Where did they go? They have to be on the here it is, on the desk somewhere. Oops, you don't fall off. So let's see if I can just use tweezers. Like this. Yeah, probably. You probably can see something. Yeah, that's not good. That's better. That's the connection we have here. Yeah. The reason to have these shrinks here, it's kinda... I made a huge mistake. I totally forgot about the... Yeah, I knew I forgot about something. So we have to unsolder it. Which is going to be a little bit harder. No. I forgot about the nuts. Okay. We have the holes. So you go in like this, then you go in like this, and then you go in like this. Or you just attach this thing right away, like this. Well, you're soldering it, at least. just attach it then. So it wasn't supposed to be here. That was a last minute addition. That's why it's so hard. Where I kind of think about it in advance, that there it doesn't get that hard. Can I even like screw this knot properly there? Oh yeah. Okay. Okay. I don't need to tighten it right now. Here we go. Attempt number 2. Good, I didn't shrink them. Oh, this one got shrunk a little bit because of the heat of the iron. Good, I didn't shrink them down. Bad that they're not going to go in the holes anymore. Try to make it thinner. It was sitting so nice and snug in this hole, and now, yeah. Yeah, God, this is the hardest part. So probably soldering it first to this thing and then to the big one. The connector would have been easier. If I broke it off and it doesn't work, then I will scream. Okay, one's in. So let's add another one. This one's still too short. Apologies, hiccups. Okay, you go here. You gotta somehow go in the hole again. And stay kind of soldered at the same time. Like this. And this way is going to be pretty strange if we're here only. Yeah. Things that I did to this fuse holder, I'll have to marry it afterwards. I'll have to check if it actually works. I will really have to check if it actually works, because it's just your basic fuse holder. It's not supposed to survive that much abuse. this in. Yes, we can, but then we will have to mount the board in like this. So something like this. Okay, let's add the fuse and check the connectivity. Just a second. A really small 200 milliamp fuse. Because this one I abused a lot. Like really a lot. When I installed the fuse, the tab kinda jumped out of it, so that part I don't like. But let's see, let's check if we have the connection still. First of all, if the fuse still working. I mean, if the socket for the fuse still working. Should be able to hear beep if there is any beeps. Okay, the fuse is in there and it's connecting the circuit. So okay, it does work. I mean, the connections are there. Oh boy. That was the easier side. To actually screw the board in at least one screw. So let's try this one. Pretty small, but we don't need it big. It just got to be there. That's it. Oh yeah, this is getting messy because of this cap. It's in the way as I expected. Oh yeah, this looks like a bad job, but at least everything is insulated. Nothing is touching anything. Unless something is touching something that we cannot see. And let's see if I can actually put the nut back on. Yeah, I can. I still can. Good. Okay, so I didn't plan for this fuse socket here. Didn't plan for it. That's why it's a mess. It's like last minute idea. That this power supply unit, since it's complicated, it has some buck converters in it. Since it's like this, it has to have some sort of protection. Okay, like this. Oh yeah. So let's see what I can shrink in there. Because I didn't. Heating up the capacitor, but it can withstand a little bit of heat. Okay, more or less not going to move anywhere. So yeah, if not that cap, it would have been way easier. But now it looks like this, like it's supposed to be like this. It wasn't. Wasn't supposed to be like this. Okay, that was the easy side. That was the easy side. The output of the device going to all the buck converters here. That's going to be the hard side. So the buck converters, they got to be like this. And then this goes from here to like all of them. They all have to be connected. So the best way to do it? Good question. Should we just chain solder them? Or split turn this one into 3? Or just solder, yeah, solder a little bit of a wiring to each one and then just solder it together and solder it to this one. That would be the easiest way. That would be the easiest way to do it. So let's solder some wiring to the inputs. So we need the thinnest ones wires I can find. And I don't have thin enough wires. So pretty much the same. Okay, give me a second. So I want to use pretty thin ones to avoid clutter again. See what I have. Okay. I have some very old thin cabling here. But of course it's enough for like the current and for the power. So, or is it? Kinda supposed to. Don't want to be losing any voltage because of the small wires, but these are actually this one's copper, so a little bit better. It has to be. These ones I just strip with my teeth. Using the same gauge of wire on this side would be an overkill, and I don't think these AliExpress devices are going to be able to actually withstand the currents the manufacturers are advertising. So I don't think it's like that good. Yeah, super dirty tip. I have a dirty tip. So the current's going to be maybe, I don't know, not even an half of an amp, I think. Less than that. It's LEDs we're dealing with, it's not like... So the white is going to be the positive and the black is going to be the negative. If I can solder it at all. Well, I can. Crap. This one is not working. Though it got soldered. Bent and soldered. Yeah, it's hard to solder when you don't have solder on your tip. Okay, that will do. Though this one's dirty. That's how it's supposed to be. So I think this one's sorta kinda, yeah, this one's going to be the middle one, because I think we don't have enough length for, yeah, for this. So let's put this in the middle one, and let's cut a longer header or whatever for the one on the other side. So this one for the one on the left side. That would be just melting. Good evening, welcome. Yeah, well, I mean, you cannot really, unless your soldering iron is like kilowatts, has kilowatts of power. So yeah, okay, good enough. Let's prepare it. And these wires, by the way, they are salvaged from old decommissioned Soviet mainframe computer. It had like seemingly like not meters but like dozens of meters of white what's it called, ribbon cables consisting of these wires under the floor connecting the different parts of that mainframe. So like dozens of meters, and it's like two only, but they were like, I don't know, 1632 wires wide, those ribbon cables, 1.1 gigawatts. Yeah, that'll do. That'll definitely melt things together, fuse just forever, if not evaporate them. Mm-hmm. Covering this in solder too. It takes so much time. It's been 2 hours already, and I'm not even half through the second one. And I actually was going to do the third one maybe tonight, but no, that's not happening. Only this one, the first one, this one. Big Toy, good evening, welcome. Yeah, I wish I could. Welcome, man. So, in positive. That'll do. Libans went to happy, yeah. They weren't indeed. Okay, that'll do. So, yeah, don't need this. So this goes like this, and then the third one is the shortest one. Got to remember not to solder ins to outs. So this one is going to be the short one. Haven't actually rewatched that. Haven't actually rewatched them in a bit. Those movies. I actually was going to many times, and something always would stop me. Okay. Oops. This one is not together. The strands are all out. Okay. Yeah, big toy, of course. Well, I mean, that's like cinema classic at this point. Undisputed. Undisputed. So, yeah. You got me. Okay, probably gonna need a little bit more solder. Oh, super. That was amazing. That worked really well. Now I'm going to need a helping hand. That just fell out. And the hole is completely closed. Oh yeah, super. So, okay. Like this. You probably could see something. I hope. It's hard to reach, yeah. There's a lot of that in this case. a lot of that in this device. Yeah, I cannot see what I'm soldering even. Okay, that'll do. Okay, so we have 3 of these prepared. Now we gotta connect them all together, connect them to this output cable. So sorta kinda make it more or less even somehow. Would it be possible? Would it be like really possible? Okay, what if I just kind of pin them down for a little bit, just to be able to do the length. Properly. So the stands I made for these, they are not like ideal, but they'll do. Oops. Yeah, I cannot even see what I'm screwing in. So cut them to the same length and then just solder them on to all together like this. Yeah, that's not really working. They're moving more or less. So like this, for example, to this length. Now have to unscrew them. Spaghetti man, yeah. Since I learned cable management in building PCs, I'm trying to use this like in here while building this basic electronics, and it's like, yeah, it's not really working all that well in this case. Okay, so now you guys, let's see if I made any mistakes here. I hope I didn't. So, but here, 1 millimeter too short. I know, right? I know, right? I always do that. That's the mess here, actually. It's not because, well, not technically because something's too short or too long. It's because I totally forgot about the fuse holder, and I wanted to have a fuse in this device, and this power supply. Well, I mean, there's fuse here on the board. That's the fuse. But if this one dies, then the whole device dies. And I kind of wanted to have an additional, well, my own fuse with like super low rating that would just burn through way before this thing starts smoking. I did it last second. It wasn't in the design, that's why this part looks pretty messy, I would say. Okay, carefully just stripping them using my teeth. Try not to bite through the strands themselves. I used it. I used it. It's like currently it's Relax Beats from Twitch, from Twitch channel Relax Beats. So that's why it's sort of kinda like this. I used Relax Beats for Helion some time ago. It was, but I used it. Ganagecha, don't remind me of those ones. I twice in my life I've seen the game going as bad as that case was. First time, long time ago in Minecraft, when the server started deteriorating, like it was multiplayer server with like a bunch of friends on it. We all knew each other, and the server started deteriorating. Like pretty much the world of Minecraft started falling apart. And then the second time was that in Helion. That was really scary. Okay. Now we need this cable, and I think I'm going to make it again pretty long, just to avoid having any problems with it. Back then in Minecraft, it really felt like the end of the world. The server was just, I don't know what it was, probably out of memory or something. And with Helion, yeah. Okay. So now we have to connect all this somehow together and add some thermal shrinks on it. So let's see. Is this one going to be enough for 3? I hope. For 4 actually. Maybe not going to be enough. Maybe not going to be enough even. Though looks wide enough to maybe fit 3 in. So, and I just add them all together like this, hoping that it just works somehow. Okay, sorta, kinda. What if I... Okay, at this point, this is an experiment in soldering a bunch of wires together. Gotta heat them up real good. Oh yeah, that's getting hot in my hands. Okay, so let's imagine we got this soldered, and can we do anything to it now? Like, yeah, we should be able to. Not sure about shrink tubing though. Might again not fit. Let's see, let's see, let's see. Yeah, of course it doesn't. Why would it? At least to some extent I managed to actually, yeah, pull it on. Okay, so we're gonna need something wider for this. This is not wider. So this is wider. I always cut them too long, and I always use the ones that are not enough in diameter. Okay, now we got to try to do the same with these ones. That was smart, without actually putting the heat shrink tubing on. Like this. Now you guys get together forever. Like this. And you soak in all this solder. In between strands even. Let's cut the excess of it. The tip is not really holding anything. So, oh yeah. When the diameter is right, it's way easier. Okay, it's not going to get better than this, so let's shrink them. And let's see if actually they're gonna go where they need to go. Yeah, they will. They 100% will. It's not like beautiful, but we definitely got them all connected. Okay, now probably the most annoying part. These connectors here, USB, which is kind of super stupid to use for not 5 volt voltage, but that's going to be like closer to 11. So these will have to be attached like this, and then soldered on like this. Well, I mean, actually it doesn't look like it's going to be that bad if we do it properly. They kinda do on the shorter side though. Wish they had a little bit more. The board's kinda a little bit on the thick side for this, so maybe I should just add them a little bit more of strippage. Just a tad more. Though when it's covered and soldered already, pre-soldered, it's actually becomes hard to strip it any further. Well, with teeth and the knife, we can do it. We just need literally a millimeter more of exposed wire. Don't know if you can see, you cannot see anything, of course. But that's just removing a little bit more insulation from the wires, nothing really special. So like this, the red one goes up, and then the red one goes here, like this. Let's see. Let's see if it's going to work. Well, I mean, it is going to work one way or another. Let's see if we can solder it here. Not like this, obviously. Not like this, not at this angle. Okay. Okay, not the best, but it will do. I just tried to cut a little bit of a finger with this small wire cutters. So you go here like this, and yeah, kinda stays. Okay, then the second one, got to do the same. First, strip it a little bit, strip a little bit more. that's the second one. Oops, lost one strand. Okay, there's still a ton of them. So you go through here, the red one up. And you go here. The red one is the positive one. Goes here. Okay, the positive one soldered. Then the negative one. It's harder because there's not a lot of solder on pre-solder part of the wire. Okay, got this. Okay. Very, very well. It's coming together. And the last one. I cannot believe I actually got to this point. Okay, that was a little bit stupid. I did not strip it. I just beat the end off. Happens. Gotta cut it better. So I told you the story about a Russian surgeon named Pirogov. That Russian surgeon in like 19th century, one of the first like recognized as not just a butcher but an actual medical practitioner and actual surgeon. Back then in 19th century that was a super hardcore profession to be like a proper surgeon. So that guy was hardcore. He could take the knife, what's it called, the medical knife, scalpel in Russian. What would it be in English? So he could take that tool, and it was his party trick. At least the legend has it, the rumor has it, that it was his party trick. He could take like the knife, tobacco paper, and he could cut through the stack of tobacco paper the exact amount of sheets per request. So that's what I'm trying to do here with just one layer. I'm trying to cut through the insulation without cutting through the strands of the wire. I was trying. Okay, so the last one, you go here, the red one up. Oh, don't tell me you are too short. Do not even start. So it will be probably not that short when I push this one all the way through. Let's do it. Yeah, a little bit problematic. Only goes in one way, won't go out. Yeah, I made the holes a little bit too tight. Like this. Whew, okay. Should be good to go. Should be good to go. That was the positive. That's going to be the negative. Sort of kind of maybe like this. Yeah. I don't want to extend them. Kind of measure that it should be good enough, and it's better to have them as short as possible. Okay, is it good enough? Yeah, it is. It's going to sit in there, just a little bit maybe tight, but okay, no, it is going to work. So now let's screw them all in and see. The last one almost ended up being a little bit too short, but almost. Making a new hole. Okay, one screw out of 6. At least the stands with the holes for the screws are properly spaced here. At least that part is done properly. Okay, that was the first one. The second one. So this is if it works, It's sort of still a little bit experimental. If it works, this one's going to be only the first one. I will need a second one. Oh boy, okay. Almost there, at least for the test. The last one is a tight fit, but I think the length is going to allow me to do that. If it doesn't, I'll leave it just on one screw. Since it's not mobile, it's stationary, it's going to be mounted and kind of left like that. Yeah, no, it will work. Under a little bit of a strain, but I'll allow that. Well, if you just move it a couple millimeters towards the main board, it's not going to be even under that much strain. Sorta, kinda, but only a little bit. Oh boy, that's a mix of things. So this goes here then. And then let's try to push these ones through. Yeah, make them really tight. I made them really tight. I was afraid of making the holes for them too big and therefore ending up with them being loose in these holes. Well, here's the consequences. Oh boy, oh boy, this looks like just a nest of cables. But the nest, that's sorta kinda more or less together, it seems. We can add a couple of zip ties, one like here, to make it a little bit more sorta organized, but that's just going to be not really holding much together. That's going to be. I cannot believe it's assembled. Okay, let's screw the board in. So some short, small ones, I guess. So could have made everything way more easier if I just left just 1 centimeter more of the room for all the wiring here. Maybe next time think about like some wire holders for like additional cable management here. Cable holders. Okay. It's awfully close to one of the caps on one of the buck converters, but well, just bend it out of the way. I guess that's that's going to have to work. Okay, our standard set of nuts and bolts to keep the mains connector in. That didn't catch the threading, but okay. This one's going to be a little easier. First, okay, this is better. This one, this one's now into. So let's attach it properly. Let's tighten it properly, like this. Okay, so the question is, will it let out the magic smoke? Time to test, because it is assembled as good as it going to be. So this one doesn't have power yet. So and let's see. Wow, that's a lot of illumination. I didn't expect the buck converters to have the LEDs. Okay, if I turn it off, well, they will die. Okay. It's like blue and green, and because there's like vents here, it's going to be pretty visible. Okay. Let's test the voltages, I guess, on a live device. Again, be careful. I do not recommend trying to do this at home. I can do because I'm stupid, but you do not try, because this part of the device here, it has the mains going on. In my case, that's 230 something volts. 230, sometimes 240, kind of never stable. So let's check the voltages. So this one is giving 1149. This one sorry, this one's not giving out anything. 1149, 1150, 1150. Let's see if we can adjust them. For that I will need a really small screwdriver. So yeah, did not really change. Well, I might need to actually do it under load. Still 1150. No matter what I do, it's still 1150. 1151. 149. They are all outputting the same voltage, which is strange, and this is outputting 1225. Okay, these potentiometers, they actually need sometimes to be turned really a lot. $11.50. I have an idea. The panels I was talking about, I have them. The LED panels. So that's gonna be bright though, but we can try. So let's see. For example, this one here. Okay. Oops. Did not work. That's not good. Something is probably shorted on the panel, or maybe the voltage is the other way around. Oh boy, I'll have to troubleshoot it somehow. Okay, I have an idea. I have this device here, USB tester, that can tell the voltages. 11.4. 11.4. 11.3. Okay. If I start turning it, is it going to change? Nope. It is not changing in the slightest. Maybe in another direction. 11.5. Good. So 11.3. Feels like we got to give it some load. Because without the load, it's pretty much outputting the power. Outputting the power of pretty much the same voltage, because the capacitors do not get drained. Unless these are not buck converters but boost converters. That would be kinda stupid. Well, if they were boost converters, I would have been able to raise the voltage all the way up. I seem to be unable neither to raise the voltage nor to drop it. That is an unexpected result, I would say. Okay. Where is the dummy load? I never can find it when I need it. Just a sec. What the hell? Okay, I cannot find my dummy load. So just gonna use this as my load. Let's just solder this on. That's going to give at least some current. At least for testing purposes. It's just a USB connector that I found with some exposed wires there. So that I attached this 10 ohm resistor. So that's gonna be some load. One amp, 10.7. Okay, 1 amp it is. The voltage is not really changing here. Oops, it's getting a little bit too hot, a little bit too fast. So 1 amp at 12 volts, that's like 12 watts, and it's rated for 5 watts only. Not big enough. guess. Let's make it a little bit less amps by adding another one in series. Oh god, it's hot. Pretty much a heater that works using USB power. Well, I mean, it's not really USB. That's like 12 volts coming through a USB thing here. Okay, so USB connector. Stay like this. I just need you to stay like this for a little bit. Just for a little bit. Here we go. Let's see if the current changes. Oops. Shorted. Didn't see that. That was a short. Yeah, the current has changed. Half an amp now. Yeah. 11. This one gives lower values. Oh, the voltage started. Finally. I screwed it far enough for it to see the voltage changing. Yeah. I wanted it to be 10.5. Okay. Got one tuned to 10.5. I'm so lucky that I bought this thing. These guys are getting hot, but not that hot. Finally got in the zone of the potentiometer. $10.5. And the last one. That's 10.9 already. $10.5. Okay, we got it tuned. All the ports here now output 10.5 volts on the load. Okay, let's run with this panel then. Why the panel doesn't want to work? It's modified, so maybe it got shorted. Yeah. The other way around. Yeah. Looks like a short. Okay, on this one. So maybe I need a different USB cable. I didn't think of that. Oh, this one's not shorted. Okay. That's quite bright, but it does. So you can see what this power supply is supposed to do. So, and let's see if we can change that by adjusting this here. Oh yeah, sure we can. It is working as intended. It is working as intended. All the ports. All the ports. So that panel got shorted because of modifications, and this panel they had to be modified. These panels, they had to be modified because they are not supposed to work with these power supplies. They're supposed to work with its own power supply, with like a sort of a small controller. But that one's hard to use if you want it to be, if you want the panel to be turned off and on by something else, some automatic device. So that's the thing. You gotta have a pretty dumb power supply in order to actually be able to just turn the power supply on and for the panels to come alive. 916, let's adjust it back to 10.5. Okay, tuned it to 10.5. Perfection. Everything just works. I thought I made a mistake somewhere in like planning this, but no, I know that I'm not that stupid to make some sort of a stupid mistake. So it does actually work the way it's supposed to. Oh boy. Okay. So that was probably one of the most complicated in terms of wiring devices I had to assemble. Where's the lid? The lid was printed separately, that's why it's white. So, but yeah. So on the previous one, I actually managed to just add to the print itself the voltage, the rating of the power supply. This one, since it's adjustable, there's no rating, so just outputs. But that you plug in your phone in this one to charge it, and yeah, it will just probably burn your phone immediately. So, but it does work. Cool. So I adjusted it to 10.5. That's what I wanted to. So these panels that I showed you, they actually have their own power supplies, but they are not dumb. They are with some logic. So, and they are adjustable too. And 10.5 volts, that's the pretty much the voltage we've been running these panels on. It's like the two that I have, they are not the two panels that I shown you, they are not attached to anything, they are not being used right now. So, but we have like 6 more. And again, these are LED panels for the plants that my waifu kinda grows a lot of. Just plant lights. So, and this device will allow the panels to be turned on and off by a switch, basic switch, or a wireless switch, radio switch, or some automatic device. Seems to be different or something. Where are the beats? Cannot see the beats. Here they are. Each we need PZ. I have PZ 0 here. No, I don't like this one. Cannot actually put it in. Cannot take it out. Stupid screw. Yeah, it's like has different Phillips head PZ. And the last one. Maybe it's a mistake actually to close it like this pretty tightly, because I might need to adjust the voltages again. But yeah, I want to just see it as a finished device. Dumb power supply that gives pretty much anything up to 12 volts on 3 outputs, and it's adjustable independently, which is, well, I mean, maybe there will be some need for that. So it uses USB-A as connectors, which is sort of kind of dangerous. If you don't know what it is, you'll destroy your phone trying to charge from this device. So probably we'll have to write it that it's not USB. So with a fuse, a small little fuse that's supposed to burn, I hope, before this thing even starts to heat up, let alone starts burning. So okay, I guess this is it for tonight. We've done it 3 hours, which is sort of kinda a lot, but well, it's this loud. So thank you very much for watching, everybody. That's the thing. Thank you very much for watching, everybody. We've assembled 2 power supplies. Where's the second one? the first one. The first one's here. So this one's pretty basic. Mains in, 9 volts out. This one's more complicated. Mains in, and anything from 12 volt and down to, I think, a couple out. So pretty much, and it's inside, it's glowing like a Christmas tree. So thank you very much for watching. At this note, let's call it a day, before actually the magic smoke leaves the device accidentally or not. Quite some people jumped in tonight. Thank you people for watching, and quite some lurkers. YouTube people, thank you for watching on YouTube. If you like this video, please leave a like. Sometimes we do exactly this, some DIY stuff, PC building, what else, well, things like that pretty much. But that's rare. Usually we play DZ or GeoGuessr on this channel. Twitch chat, thank you people for watching. Gonna Getcha, Big Toy, Captain Pyra, thank you for jumping in and lurking. Now it's somewhat time to find somebody to raid, though not a lot of people left in my Twitch chat, but we still can, I think, do it. So just give me a second. Just bear with me. Okay, so maybe it would be actually fitting to go to friend of the channel Nate, who is learning S.M.S.L and Blender right now for, I guess, game development. So let's start the read. Yep, let me post the link in the chat. Oh, my cap chat's alive. That's strange. So it would only appear after some time, but never from the start. It's like needs to warm up, my cap chat. So thank you very much for watching. I will see you all tomorrow. That's it for tonight. Some success, which is always cool, but time to call it a day. Goodbye and good night.